In this video, I'm going to go through pH calculations and how to recognise which calculation you should be using. So you should remember that all pH calculations are based around this, and this is the answer that you would give if you were asked what is the definition of pH. You would give this equation. Now there are a couple of different ways that you might use this calculation. For example, if you were calculating the pH of a strong acid, then you would just use that calculation as it is. And you would need to remember that the concentration of H plus is equal to the concentration of the acid. Exceptions to that would be acids such as H2SO4, in which you would need to double the concentration of the acid because obviously it contains two acidic protons. Next example, we've got weak acids. Okay, for weak acids we can't use that calculation straight away. You need to use the one with the square root in it. And that looks like this. The giveaway on this question is that you will get a Ka value or a pKa value. Remember that strong acids don't have Ka values, so if you see a Ka value, you know that it's definitely a weak acid. Following on from that then, we've got bases. Okay, so if you see a question asking about a base such as sodium hydroxide, calcium hydroxide, anything to do with water, anything that mentions hydroxide ions, then you know that you're using the Kw calculation, which is this one. And you might need to rearrange it, but that's the basis of it. And the final example, you might be asked to use pH calculation to calculate the pH of a buffer. There will be another buffer tutorial on calculating pH, but I'm also going to include them here for practice with recognising them. If you get a buffer question, then you are simply going to use the Ka expression. Apologies that that's out of line there, but you would just use your Ka expression. Obviously with all of these expressions, once you've got the H plus concentration, so there, or you would rearrange this to give you H plus here, or you could rearrange this to give you H plus there. Once you've got the H plus, you would then put that into the pH calculation to get the pH. Next we're going to look at some examples to give you some practice with doing this. In this example, you're asked to calculate the pH of a calcium hydroxide solution. So if you want to have a go at this example, pause the video now. Okay, so if we notice that we're talking about calcium hydroxide, which means that we're going to be using the Kw expression, because obviously this is a base. So the first thing we need to decide is what's the formula of calcium hydroxide, and that's this. And then we need to find the concentration of OH minus ions. Let's just write the Kw expression up here. So hydroxide ions is equal to 2 times the concentration of calcium hydroxide. Okay, you'll notice that we're needing to times that concentration by 2 because each calcium hydroxide contains 2 hydroxide ions. So that's 2 times 0.15 gives us 0.3 moles per decimetre. Then I'm going to go to the Kw expression. If I want the pH, then what I need to be able to do is minus log of H plus. Therefore I'm going to need to rearrange the Kw expression to give H plus equals Kw divided by OH minus. Put the numbers in. Remember Kw is 1 times 10 to the minus 14. You don't need to remember that, it's on your data sheet in the exam. We've just said the concentration here is 0.30. Put those into your calculator and find the answer, and you'll get 33 times 10 to the minus 14. Remember that's the concentration of H plus, so that is moles per decimeter. Also remember that I've rounded this number, but you should leave it in your calculator until the very end of the calculation to make sure that you don't get any rounding errors. So once I've got the H plus, I'm now going to do minus log of H plus. So again, I'm just going to keep that number in my calculator and minus log it. And that gives me a pH of 13.48. In this example, we're calculating the pH of some sulfuric acid solution. Pause the video if you want to have a go before I tell you the answer. Okay, so things to notice. Sulfuric acid you should recognise as a strong acid, which means that we'll just be using minus log of H plus. However, you should also know that sulfuric acid has the formula H2SO4, so it contains 2 acidic protons. So the first thing that we're going to do is get the concentration of H plus ions. Okay, so it's going to equal twice the concentration of H2SO4 because of those 2 acidic protons. And then it's just a case of minus logging it. Which gives us minus 0.48. Remember that in A-level chemistry you are allowed minus pHs, so that's fine. And bearing in mind that it's quite a strong solution of a strong acid, it is going to be a very low pH. In this next example, we've got 2 different acidic solutions. One contains nitric acid and one contains ethanoic acid. Pause the video now if you want to have a go before I go through the answer. Okay, so the things that we're going to take notice of then in this question are that nitric acid is a strong acid, but ethanoic acid is weak. So they're 2 quite important distinctions that we're going to make. So for strong acid, we can use minus log of H plus. Remember that H plus equals the concentration of the acid. This acid's only got 1 acidic proton, so we're fine with it as it is. So the concentration of H plus ions is 0.2 moles per decimeter. And all we need to do with that number is minus log. Okay, so the pH of the nitric acid is 0.7. Then we're going to deal with the ethanoic acid. Okay, we know that that's a weak acid, 1 because it's a carboxylic acid, and 2 because we've been given a pKa value. First thing to think about is which equation we're going to use. So to get the concentration of H plus of a weak acid, we use the square root concentration. To get Ka, we can see that that's in the equation, but we've not got Ka, we've got pKa, so K equals 10 to the minus pKa, so So 10 to the minus 4.75. So now we've got Ka, which we can put into that equation. And concentration is 0.25. We should calculate the answer to that. And you should find that the answer is 2.11 times 10 to the minus 3. If you've got slight differences in your answer, it may be that you've not left your answers in your calculator and you've rounded part way through. Make sure you're not doing that. So if we've got the concentration of H+, then we can use minus log to get the pH. So again, leave the numbers in your calculator and just carry on from there. And that gives us a final pH for the ethanoic acid of 2.68. Should expect this answer to be in the region of 3 marks, where I've underlined in yellow. Maybe 1 or 2 for the method, but a minimum of 3. So in this example we've got a solution containing ethanoic acid and sodium ethanoate. Have a think about which of the equations you're going to use. Pause the video and have a go at it now. Okay, I'm going to go through the answer. So we've got a solution containing ethanoic acid, which we can see is a weak acid because we've got Ka value. So you might be initially thinking the weak acids calculation. However, we've also got sodium ethanoate. So that would be this. So what we've got here is an acid and its salt. So now you should be thinking buffer equation. Remember that the metal is unimportant because that's not involved in the buffer equation. So we can essentially ignore it. And there we have our conjugate base of the acid that's up here. So if we're thinking buffer, we'll be using the Ka expression. Like so. What we need to do is to rearrange that to get H+. Okay, so that should be a rearranged equation. Then we're going to put the numbers in. Concentration of the acid is 0.1. The ethanoate ion is 0.05. Then we need to put that into our calculator and find out the answer, which is 3.52 times 10 to the minus 5. That's the concentration of H+, so it's moles per decimetre. Certainly going to get a mark for doing that. Once we've got the concentration of H+, we're going to then minus log it to get the pH. So again, leave your answer in your calculator until you get to the very end of this question so that you don't introduce rounding errors. You should get a pH of 4.45, which would be about right considering that we're using a weak acid for a buffer. Okay, in this example we've got benzoic acid. It's asking us to calculate the pKa and the pH. Have a think about which of the calculations you're going to use. Pause the video now and have a go. And now I'm going to go through the answer. So, if we've got a Ka value, we know we're talking about a weak acid. It's asking us to do the pKa. There's no mention of any salts or conjugate bases, so therefore it's definitely just going to be using the weak acid calculation, which is this one. for those of you who can't remember from F324, which we will be covering, benzoic acid looks like this. So it is a carboxylic acid, which we would expect to be a weak acid. And all we need to do is put our numbers in. So square root of 6.46 times 10 to the minus 5, and the concentration of the benzoic acid is 0.3 moles per decimetre. And the answer to that should be so that is the concentration of the H plus ions, so that will be in moles per decimetre. And then we do minus log of the answer, which gives us a pH of 2.36. That will be a second mark in this type of question. It also asks us to calculate pKa, so I'm going to do that over here. Just remember that pKa is equal to minus log Ka. So if we do minus log the Ka value, then we should get 4.19, and that should be a third mark. In this question we've got the pH of a solution of sodium hydroxide. Think about which calculation you're going to use and how, and pause the video now whilst you have a go at it. Okay, so if we're looking at sodium hydroxide, we know that that's a base with the formula NaOH. That means that we're going to be using the Kw expression. Then we're looking over here and we're seeing that we've been given a pH. So if we've got a pH, we're going to convert that into H plus concentration by doing 10 to the minus pH. And then I'm going to work from there. So the first thing we're going to do is find the H plus concentration. So I'm going to do 10 to the minus 13.35. This gives us a concentration of 4.47 times 10 to the minus 14. Then we're going to look at our Kw expression. And we should remember that for bases, OH minus equals the concentration of the base of the alkali. Okay, this applies to bases like sodium hydroxide where there's only one OH ion. We'll look at some others where there's two OH ions as well. So in this case we're going to need to rearrange this to give us the concentration of OH minus. And we're going to put those numbers in. Remember, this number you should have left in your calculator to avoid rounding errors from earlier. And that should give you 0.224 moles per decimetre. So the concentration of sodium hydroxide, which is the same as the concentration of hydroxide ions, is equal to 0.224 moles per decimetre. If you were to get this as a question, you'd have a mark for your final answer and you'd have a mark for your concentration of H+. Three different acids. Have a think about which calculations you're going to use. Pause the video and have a go. Okay, so going through this, we've got hydrochloric acid is strong with the formula HCl. Sulfuric acid is strong with the formula H2SO4. And phosphoric acid is weak, which we can see because we've been given a pKa value. So now we're going to answer the question, so we'll start with HCl. And we should remember that H plus concentration is going to be equal to the concentration of HCl because it's a strong acid and it's only got one acidic proton. So we're going to do minus log 0.6, which gives us 0.22. That's going to be our first mark if this was a question. For H2SO4, H plus concentration is going to equal 2 times the concentration of H2SO4 because there are two acidic protons. So 2 times 0.6 equals 1.2 moles per decimeter, and then if we minus log that, we get a pH of minus 0.08. Finally, we come to the phosphoric acid. A couple of things we need to do here. First of all, we're going to need to convert this pKa into Ka, so remember that Ka equals 10 to the minus pKa, so 10 to the minus 2.12 gives us 7.59 times 10 to the minus 3. We should get a mark there. And then because it's a weak acid, we're going to use that square root calculation. So all we need to do is put the numbers in. Remember, leave your answers in your calculator all the way through the calculation so you're not introducing rounding errors. We've got the concentration of H+, so we're going to do minus log of H+, which gives us a pH of 1.17, and that would also gain us a mark in this question. In this question, we've got a mixture of nitrous acid and sodium nitrite, which would be NaNO2. So again, think about which calculations. Have a go, pause the video now. So now I'm going to look at this. We've got a weak acid, and over here we've got a salt, which would be its conjugate base, because remember that we can ignore the metal. If we were thinking about the dissociation of this acid, we'd have HNO2 making H plus and NO2 minus. So what we've essentially got is the mixture of a weak acid and its conjugate base. That should point you at the buffers calculation, which is the Ka expression. We need to rearrange that to get H plus. And then we need to put the numbers in. So Ka is up there in the question. Concentration is also up here. And the concentration of the nitrite ion is there. Calculate the answer to that, which is 0.0000381 moles per decimeter. So we should get a marking point there. Once we've got the H plus, then we do minus log. Remember, leave it in your calculator all the way to the end, which gives us a pH of 3.42. In this example we've got chloroacetic acid, you've got the formula there. We've got pKa value and it's asking us about the dissociation. So work your way through the calculations, pause the video now. Okay, so now I'm going to look at this. If I've got a pKa value, then I'm going to convert that into Ka value by using Ka equals 10 to the minus pKa. So you should get a mark for your Ka value. Then it's telling us that it's a weak acid, so we're going to be using the square root equation. And we simply need to put the numbers in. So we've just worked out Ka. We've got the concentration up here. We just need to calculate. Gives us 0.0188 moles per decimeter. It's actually 1879, but I'm not going to round it in my calculator. Then I'm going to put it straight into the minus log calculation to get the pH, which gives me a pH of 1.73, and that will be another 2 marking points there. An example of this type of question, which quite often catches people out. So it says pH of a solution where the concentration of OH minus ions is 200 times greater than the concentration of H plus ions. Think about which calculation you're using and pause the video now. Okay, so I'm looking at this question. If I see OH minus ions, then I know that I'm using Kw. Okay, if I've got a very nice mark scheme, it might give me a mark for just writing that equation, so I always put it. Then I'm going to say that OH minus equals 200 times H plus, and then I'm going to substitute that into the Kw expression. So Kw equals H plus, and then instead of writing OH minus, I'm going to sub in this. Okay, so I can say that that is equivalent to saying OH minus because OH minus is equal to 200 H plus. So all I've done is replace that term in the calculation. Then I'm going to rearrange it. So Kw divided by 200 equals H plus times H plus, which is equivalent to H plus squared. And then if I say square root of that expression just gives me H plus. I'm going to put the numbers in. 1 times 10 to the minus 14 is Kw, remember that's on your data sheet, divided by 200 and square root that answer. Gives me 7.07 times 10 to the minus 9. Finally, if I've got the H plus concentration, I'm going to do minus log H plus, which gives me an answer of pH 8.15.